Welcome again, Alexei. Let's solve some another problem. Today we go. Today we go for the last warm-up challenge. Sock Merchant. I have no idea what it's about, but we'll see. And after this, later on we will start with more harder ones. I will not read the problem itself today, and will only notice only some things. So if you want, you can set to pause and read by yourself. Yep. The idea that we have an array of integers. So in this example, there is seven integers, and we need to find how many pairs of each sock we have. For example, we have three socks with number 1, so it's only one pair. And one last sock is doesn't mean anything to us for now. So there is 3 odd socks left of each color, and the amount of pairs is 2. So 2 socks with number 2, 2 socks with number 1. We need to go through an array somehow and find out how many total pairs we have. To our function, we got 2 arguments. First one is the number of socks in the pile, and the second one, the colors of each sock. So this is an example. Okay. Input format is not so interesting, since we anyway got an object and some code is ready for parsing the data itself. Let's see at constraints. From 1 to 100. So we have only 100 socks, which is not a lot. So this is small numbers, and there certainly will no problems in optimization or whatever, since the number is very small. Of course, it's possible to write some algorithm that it will be slow, but generally it will be not as easy. Okay, so we need to return the total number of matching pair of socks. So and sell. Yeah, right. But I think if you're good seller, you also can sell odd socks as designed ones. What do you think about this? Okay. See, we have some small explanation here. We have an array of integers. They just randomly put it on the screen, but also they connected just to illustrate the pairs itself. How you by yourself will able to find the pairs? For example, you got a lot of socks and you need to find the pairs. What you will do? Okay, then what you do with the socks? Okay, So you remove these socks from the pile, right? What happens with socks for which you doesn't find a pair? Okay. 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 Yeah. Okay. So we can start with trying to implement your algorithm, exactly what you had told. So we will go through an array. We will take the first sock and we will try to find another same sock, same color sock. If we found it, we will remove both of them and then we will repeat this operation. So, but we will start with the next one. Sounds good? It's not optimal solution, but we will come to the optimal one a bit later. But the main thing that there should be a solution first and optimization later on. So number of socks, let's rename it. Number of socks. And second one is colors of each sock. Okay, we have these two variables, and now there will be a bit tricky part how we will go through an array, since we will modify the array itself on the fly. So we have first of all, we need to add a new variable that will count pairs. So pair count. Initially it will be 0, of course, and we will return it. What's wrong? Just small typo. So let's start with a simple cycle. Then we will modify this cycle for a bit different thing. So we will go from the first sock until the last one, and we will go for another sock each time. So we will have current color, and we will go again through this array trying to find the same color. We will start with let it be k equal I plus 1, so it will be like we're starting search from next sock, and we will go the same until the end. Just need to change to k. So we will compare our current color to the new one. So and if we will find the color, first what we need to do is to stop this cycle. We need to increase pair count, and we need to remove both of these socks from an array. Let's modify this array. Generally, it's better not to modify incoming variables, but for the purpose of this task, that's fine. So we will remove both of them. For removing items from an array, there is operation called splice. And first we will remove the second sock. And I didn't remember, is it modify array itself or... Okay, I think it's modify array itself, so we don't need to do it by ourselves. And other things, I think that we need to do here is to modify counter itself. So since we remove two socks, one from like future and one from current, we need to like move one step back for the reason that we want to start with the same number of sock. Like if we find a pair for first sock and remove it from pail, then other sock become the first one. Understandable? Okay, so I presume that's all, and we can try to run this code. And it's not working. Okay. Let's try to understand what goes wrong. So our output was 0, so that means that we didn't find just one of them. So like, what is the reason why we was not able to find just one pair? We can try to debug by ourselves or try to use debug output. Generally, it's a good idea to learn how to debug code by yourself without try to write debugging information anywhere. So we can try with that. First of all, the code is not stuck, so there is no unlimited cycles or anything like that. So with we can not worry about that. But like, why we did not get here? Maybe socks color is not an array. No, I want to try to see initial variables. Also, number of sock doesn't matter anything for us for right now. So I want just to see what is inside of socks color. So no, that's everything is fine here. We have an array of integers. We go through this array. Right. There is no mistake or anything like this. And I think we can remove this variable. It's unnecessary. But generally nothing is changed from this point of view. We remove. Looks like this code never works. So let's try to debug it. So we will just run and see that there will be no such message. Yes, there is no such message, but like, what is the reason? Let's see. First of all, let's see how many socks we have here, and just to compare. And then we will try to print both of our variables and see what the numbers of them is compared. Also we can add both of them here and see what is happening. Undefined. Interesting. That's strange. That's strange. It's array. Let's check code again. What we have here? We have an array. So I'm sure this is an array, and every array. Let me just print one more time. By some reason, it doesn't have length. Like, why it doesn't have length? Just a second. It's very strange behavior. Let's try to print the color of the first sock to see what's happening. It's fine. It's fine. Of course, we can use the number of socks instead of the length of an array, but it's not so good because I don't want to use like another variable to count by myself instead of just using built-in functions. There is no typo, right? Let me just try to create another array, try to run it, just to see that there will be two. Yes, everything is fine. So I have no idea what kind of problem it is, what kind of problem here. So we will go to like backup option with using number of socks variable instead of length. The problem here that we will need to modify the number of socks also. So in addition to increase pair count, we will remove 2 of socks from these numbers. This also fine. I generally better to use previous approach, but don't want to spend too much time of finding what the problem is here. So everything is fine, everything works as expected. I'm not sure if it was like my mistake or there is something go wrong in the compiler or in what level, but generally your idea worked well. So we was able to solve this task. Let's run and see that. Congratulations, you solved it. Nice. Yep. All right, now we'll try to calculate our time complexity, space complexity, and find how we can optimize it. So we'll start with the space complexity. Do you remember what is it? Not the code, but how many memory it uses. Okay. So generally we introduce only one variable that not increase amount of memory consumed by itself. So the space complexity will be 1. Like we use our arguments and other things. So space complexity not modified. But it will be a bit harder than in previous task for the time complexity. Since this time we have a cycle inside other cycle. So first cycle happens number of socks times, and second one also happens number of sock times. And inside of them there is just it's not just simple operations. Generally these operations not the cheapest one, since it's modify array, reduce its size and so on, but we'll not focus on this, or we can. Okay, we can focus on this a bit later. So, but generally we make number of socks by numbers of socks, so it will be n square time. So if we have like 100 socks, we will go for like we take the first sock and go to the end, then take second sock and check the sock with each other one and so on, and it took a lot of time. If we have just 4 socks, it will be fast, but if we have 100 socks, then we will need to perform like around 10,000 of operations. There is less than 10,000, of course, since you're moving through the pile and doesn't compare with previous one. But anyway, it consumes a lot of time. And the operation of removing element from the array is not easy one, because for computers generally there is a lot of optimization done for such things, and the operation itself I did not remember exactly how it happened, but what is happening here is the new array is created, and not new array, sorry. The element is removed from array, and all the elements from the end move it like by one position. So it can take up to length of the array. So it's can take up to another number of socks operation, and we do this like 2 times inside. So it may be that we have even n cube here just in case of these operations. So like a lot of time used for like nothing. So the first idea is to get rid of somehow of this part, so we will not modify an array itself. It's fine to change a value to some another value. So for example, we can do it like this. So let's do like first iteration of our optimization. We can change this variable to null. So then we will just ignore this value later on. So if it's null, then it doesn't mean anything for us. So if it's null, then we go to another one. And we will also, with this approach, don't need to modify I and so on. So let's try to run our code and see that it works fine, and it doesn't work fine. Like, okay. Strange. Let's debug it again and see what we have in socks colors in the end. So initially we have these four, and they were replaced with nulls, which is fine. Then we go for this pair, and this pair also should be replaced without any problems. Because we remove socks from pile, and right now we don't need to remove socks from pile since we want to count like all of them. We just replace them with something that nothing. Like they still place it in a row and everything is fine. So we remove this heavy operation and we get back to n square, which is a bit better than previous one. But this is still not an optimal solution. To find an optimal solution, we need to get back to our conditions. And by our conditions, we need to find count of pairs, right? So we don't need to like put them in other piles or to do anything else. We just need to find how many pairs we have. So maybe you have some assumptions. How can we find a pairs of socks with different colors? Yep. Can you we can compare them by color, of course, but can you do it by going through all the socks one time? I mean, to if you will see every sock just once, will you able to understand how many pairs of them you have? For how? For example, for this example, we have 9 socks. Okay. And how you will do it by yourself? Try to explain. Like, I show you the green sock. Okay. Then I show you blue sock. Then I show you another blue sock. Then I show you another green sock. What happened at this moment? How? Okay, okay. Great. So you had count the pairs of each colors. Not the pairs, you had count how many socks of which color you have. Yeah. So we can try to create additional data structure and count how many socks of which color we have. Let's create this structure. This will be, let's rename this to just socks. I don't like the socks color because I want to use this this name for now. So socks color will be an object, and we will have the structure inside of this object like this one. So for example, if we have color 20, we'll have 0, no, not the 0, at least 1. If we have 30, for example, it will be 2. And then we will go through this object and see how many pairs we have at the end. So we go through our socks right now and put each sock inside the sock color. Socks color. So we will increase the value by 1, but initially there is no such value, so we also need to set like initial value. So it will be the value that we have right now or 0. So and plus 1, of course, plus 1. Then we will go through socks. So we're getting each color of sock and we go through of them, and we have count. So we can increase pair count. Pair count will be increased by count divided by 2. So we divide count of each sock by 2. For example, if there is 3, we'll have 1.5, and then we round it to the floor. So it will be 1. So if we have 3 socks, it will be 1, and we add it to the pair itself. Let's see, is this code work or not? We have 55. Close enough. Let's see what we have in socks color. Sorry, my mistake, because I got it, because I make a sum not of the count. We have color here, not a count, but color. I want to put it on the next line, just to have a bit more space. So yes, by this way we can get a color. So we going through keys of our object, and for every key we have a value. So right now everything will be fine. Generally, it's better to avoid such type of errors on interview, or like fix them fast as possible, because you will not have ability. Sometimes you will not have ability to test what you had right at all. You will able to only do it in your mind. So we will run our code again against all the tests and see that everything fine. So what is changes here? That we add additional data structure, and this data structure in like worst case we will have a lot of socks with just one color. No, a lot of different color socks. I mean, all of them will be different color in the worst case. So this data structure, for example, can consist then, if we have maximum of 100 socks, this will consist of 100. So the space complexity will be O(n). So we move from O1 to on. So our memory consumption is increased. So we use more memory. But time complexity was on square, and we move to we do this calculation just once for every sock, so it will be on but by number of socks, and then we go through our object, which is also n, another just once. So we have another on here. But so combine it will be like O to n. But constants doesn't matter anything, so we just drop them. So at the end we have just on. So it's like we pay a bit of memory to have more optimized algorithm. But generally, like this, our new solution is better than previous one, since it with the increasing of amount of socks, it will still work fine and will not consume a lot of memory, and amount of memory will be depend only of count of socks, which is like fine for us. And time complexity will be increased linearly. So for each sock we will need perform like 2 additional operation, which is fine. And with the previous one, for each new sock we will need to perform n square operation. So for like 10 additional socks we will need to perform 100 more operations, and so on. So any questions? Then that's all for today. For tomorrow, I hope we will start to solving not just warm-up tasks, but something more complicated than easy ones. And we'll see how it goes. Thank you a lot. Have a nice day.